Summit.
Holy moly, this is the
Holy
kickoff session. We are rolling here. We're 1 minute to go. 1 minute till showtime. We've got our speaker here. Joe Boaler is here. We're excited to kind of introduce folks. Welcome. This is the kickoff session, the opening night of the 2024 Make Math Moments virtual summit, sixth summit. We're excited to bring you a weekend of amazing sessions. We're going to start this off with Joe Bowler's session. So we're excited. Get yourself in the chat. Let us know where you're coming from. We love to see whereabouts in the world you're coming from, where what your role is in teaching. That chat is going to be flooded. We're at about 800 people in the room right now. Turn your cameras on. We'd love to see you. In the meantime, though, leave your mics off unless Joe says, "Hey, let's have somebody answer this verbally." But do us a favor there. Get yourself in the chat, and we'll get going.
Yes, yes. Welcome, everyone. Just a heads up, throughout the entire weekend, we have all of your replays available. So we know that you're not going to be able to see 40 something sessions, John, is it this year? It's going to be tough for you to fit it all in back to back to back. So if you are interested in extending, know that you can extend your virtual ticket. And of course, the best deal is to get yourself not only a ticket, but also an all access pass to the Make Math Moments Academy, where not only this summit is hosted, but all of our online courses, as well as our past summit replays, are active. So feel free to head on over in the summit site. You can pick up one of those tickets. And for those who are wondering, yes, there are certificates of attendance. So on the Summit platform, make sure you head on in there and take a look and see and look for the attendance certificate button so you can generate those at the conclusion of the summit. And if you haven't yet, make sure you subscribe to the Make Math Moments podcast, where we've been hosting for, John, is it 5 years now? Are we at 5 years yet?
We are. This is
5 years, I believe it is. Might be in our 6th year, and we've actually brought on a teammate to join us, and she's here with us tonight. Yvette, you may have heard that voice on the podcast over there. There's Yvette Lehman. She's waving. So you'll be seeing her throughout the weekend as well. And hey, make sure you stick around during this session, because Corwin is one of our awesome summit sponsors. They've been with us for this entire process from start to finish, from the very first summit to this being the 5th summit. And you can stick around to get a door prize from this session. John, how about you help us out with introducing our
You got it.
speaker,
You got it.
guest of the podcast, and an amazing math education leader.
Let's do this. We are pleased and honored and proud to welcome our opening speaker, Dr. Joe Bowler, Stanford professor, author of 19 books, numerous articles, also on, leading and heading up the writing team for the 2023 California Mathematics Framework. You've probably been to her website, YouCubed.org. Recently, the new book, Math-ish. We also just interviewed her on the podcast. That episode came out in the summer around that book, but we're excited for her to be here to talk about math-ishing. And Dr. Joe Bowler, we're gonna hand it all over to you. Here we go. This is your session.
Thank you. And hello, everybody. Wow. I can't believe how many people we have in this Zoom. I'm just watching the numbers going up, waiting for it to break when it hits 1,000.
I was just going to say, I'm a little cautious. I'm a little concerned here. John and I are going to do some button tweaking in the background to see what we can do.
Because I was told that can't go over 1,000. And look, if you look at the participants at the bottom, it's going up to, anyway.
We're getting close.
We will just enjoy ourselves, and it is great to see you all. Thank you for joining me. I'm thrilled that you were able to make it on this, what might be Friday night for you, but might be some other time of day entirely. Or it might be Saturday. I see some people here from New Zealand, so we've got people from all over the world. Fantastic. Oh, I already did something wrong. I've got to stop sharing because I have to remember to hit the button that I need to hit. All right, here we
Well,
go.
let's blame it on the Zoom room, right? It's the amount of people in the room, right?
I got it. All right. So I'm going to talk to you tonight and share with you some ideas for my new book, which is called Mathish. And in case you don't know, I am one of the co-founders of YouCubed. Our website just went over 67 million visits. I love it when we go just over another million. And if you don't know about YouCubed, I'll let you explore that on your own. But I want to share with you that I had a couple of books out a year or so ago, Mathematical Mindsets, Limitless Mind. I wrote Limitless Mind because so many people who read Mathematical Mindsets told me, you've got to get this out to other people. You've got to get it out to parents, to administrators, to people who won't read a book with maths in the title. So Limitless Mind. But as you heard, I was one of the writers of a new framework in California, the California Maths Framework, unanimously passed despite a lot of pushback from some elite STEM people, shall we say. And that pushback was pretty nasty. In fact, Stanford gave me some sabbatical time to recover from this period of time. And I was wondering, what shall I do with this? It was just a quarter, but they gave me a quarter where I wasn't teaching. So I thought to myself, I need to do something productive. I decided I should write a new book about maths. It had been 10 years.
The author that I just met last week.
It's been 10 years since I wrote Mathematical Mindset. So I thought there's lots of new evidence now, lots of things I could write about. So I decided to go away for this quarter sabbatical. So I was out of all of the craziness of Stanford. And I actually rented a little shack in the mountains. This is the shack. It was just at the back of this, actually. It was a tiny little shack. And last winter in California mountains, it got very snowy. And in fact, as my winter quarter went on, it got snowier and snowier to the point I could hardly get into the shack. I took my dog with me. She's called Dougal, and she hates water. I didn't know what she'd be like with snow, but here she is. Not too happy in her snow encounters. But I don't know whether it was the snow or being locked away, but out of this came this book, Mathish, with this explosion of creativity, as you can see on the cover. So I'm going to tell you a little bit about Mathish today, but there's a lot in there, obviously. I start off talking about how most people need a different relationship with maths. And I have a whole chapter of ideas of how to teach kids how to learn. I know that many of us as maths teachers think we're there to teach maths, but actually students really need to learn how to learn maths. And I teach a class at Stanford called How to Learn Maths, and there's a lot of that in that chapter. But tonight, or today, I'm going to focus on a couple of the ideas from chapter 4 and chapter 6. So I'm going to start off with that question of how people learn and say that there was a really important really important book published a few years ago by the National Research Council in the US. And they wanted to summarize what they knew about how people learn. So they called it How People Learn. And this is an extract from that book. Superficial coverage of all topics in a subject area must be replaced with in-depth coverage of fewer topics that allow key concepts in the discipline to be understood. The goal of coverage need not be abandoned entirely, of course, but there must be sufficient number of cases of in-depth study to allow students to grasp the defining concepts in their discipline. So what does this mean? In maths, I think one of our biggest problems is there's too much in the standards, in the curriculum. Teachers really have a hard time trying to do what they want to do, which is have students work in depth, exploring topics, making connections when there's so much to teach. So this was part of the initiative of the California Maths Framework. We reorganized all the standards into 8 or so big ideas in each grade level. And this can be for anybody. It's not just for California. But the idea of this is if you can just focus really in depth on those 8 ideas, big projects that kids take lessons to do where they're making connections, and then that will ground everything they learn, even if the rest of the time they're working through narrow topics and narrow questions. And so here's a couple of our big idea maps, grade 3, grade 5. And of course, we have our books that go across grades K to 8, sharing lots of rich tasks. So I thought something else that's in the book that I wanted to share with you is I did a lot of studying of expertise, studies of expertise. What do they know about the way experts hold knowledge? And this is what they know, that experts hold knowledge, somebody with real expertise in maths, their knowledge is held in a connected way, not as separate little topics. So when kids get an experience of maths that's just separate topics, one after the other, no connections, they don't hold connected knowledge. And that's really a problem for them when they're trying to problem solve, because if your knowledge is connected and you're doing a problem on ratios, but maybe you remember something about operations, then those connections will lead you to ratio. So connections are super important. We need to make connections for kids, connections between mathematical ideas, connections between maths in the world. And yeah, so talking of connections, you may have seen me share this before. I work with a neuroscientist called Vinod Menon, who has shown that our brains, there are 5 different brain areas that want to process maths. And actually, what we really want is those 5 different brain areas to make connections, to build a connected brain. And that connected brain, I'll take my jumper, that connected brain comes about when we see maths in different ways. So not just as numbers, but maybe we also see it visually. At the back of the head are these visual areas of the brain that see maths visually. Or maybe as with words, maybe we're writing about maths or graphs or algorithms, tables, models, maybe we're moving with maths. This is what builds these important connections. So conceptual connected learning, it's deeper. It's about reasoning, being skeptical, visualizing. And I thought I'd give you a little experience of seeing this by posing this question for you to think about for a minute. You are told that you need to figure out how many pennies there are. And this is what you know. When pennies are put in groups of 2, there's 1 left over. When they're put in groups of 3, 5, or 6, there's 1 left over. But when they're put in groups of 7, there are no pennies left over. So how many pennies could there be? You could think about this and share for me in chat how you would approach it. Oh, we have some conjectures already. Somebody says 49. Interesting. Let's think. If you divided 49 by 5, how many would be left over? I'm not going to tell you answers now. There's some conjectures of 7, 14. Christy says it will be a multiple of 7. Some people are saying they'd look for multiples of 7. I can tell you this looks easy, but actually is pretty complex and cool. It's very cool. So I'm going to not have you do this whole problem because that would take up all our time. But we're going to watch some 4th graders work on it. I was asked to share a teacher teaching conceptually to big ideas for an OECD presentation. And I went to a 4th grade teacher I know who's amazing. And she told me she was going to do this task. I had only, up to that point, I'd only seen this question done with high schoolers. It's actually... Sarah says maybe 301. Somebody says 181. It's actually a sort of derivation of the Chinese remainder theorem. So let's have a look at some 4th graders tackle this. And this is a teacher who teaches the big ideas conceptually. And let's see what she gets. And afterwards, I'd love to hear what you think. During sharing.
Today we are going to do an activity that is very similar to the activity that we did yesterday, where we have to find a number.
When you first started adding up the harder stuff, I wouldn't get it so well, like I wouldn't understand so well. And I didn't ask questions because then I thought everybody would say like I wasn't that smart.
When everybody else was like getting it and was answering the questions, I got really worried that I wouldn't be able to get it.
When the pennies are put in groups of 2, there's 1 penny left over. When they are put in groups of 3, 5, and 6, there is also 1 penny left over. But when they're put in groups of 7, there are no pennies left over. How many pennies could there be? What does it mean when we say groups of? What do you think that means?
That means like something about groups of specific numbers, it says, when it's asking about it.
Okay. Can you give me an example just to make sure?
For example, 5, there's groups of 5, 2 groups of 5.
When my teacher helped us have a long time to answer our questions, it felt like answering a problem wasn't exactly impossible. You could like figure it out.
Now, yesterday, we had a bunch of tools that you could utilize to help you. And you can use anything you want, anything that you think you and your partner would need to solve this problem.
I think as a child, you feel powerless sometimes. And so in my class, I absolutely try to give the students choice in lots of things. I have regular seats. I have places where kids can sit on the floor. They just need to make the right choice. What's best for them to work successfully?
I have an idea. Why don't we use the 7s first? Because then we can figure out firstly how much groups of 7. That is a good idea.
In math, you could tell that some people didn't understand so well, and we could just ask questions freely without being judged. We felt safe.
I'm pretty sure 23 would work. Let's read the problem again. Answer is when all these match the criteria and they're like 1 remaining left.
Like, for example, it's fine to make mistakes. Like, if you go fast in math, it's more likely to make more mistakes.
Some people can go really fast and get all the answers right, and some people can go slow and still get all the answers right, and it's okay to go at your own pace.
When I first came across Jo's work, I thought that it really spoke to me in that she's directly hitting a need we have with kids learning math, which is everyone is struggling at some point, and whether your struggle is now or your struggle is later, if you stick through it and you utilize things around you, friends, the internet, manipulatives, whatever it is, that you can find yourself through it. I think the most important thing that I wanted to show today was that my students embraced the struggle, that no one gave up, not one group, no matter how hard it was.
The process of a pit was like the top was like something that was easy, and then when you start going down, it's like when you don't understand the problem and you start getting worried and you get confused. And then when you're climbing out the pit, it's like when you're getting relief and like you're understanding the topic, and this topic is getting more and more easy for you.
The amount of brain work that's going on right now is unbelievable. If we stopped right this second, I would be just satisfied knowing that this stumped so many people.
So I think the string would connect from one concept to the other concept, and there would be a little paper and it would have like why they are connected together. When I looked at the string and the little answer, it helped me understand why those two concepts, I can use them together. It was the students who were coming up with the connections. So a student would raise their hand and say how those two concepts are somehow related.
I just think it's so important that people start adopting this type of teaching in maths, but also everywhere. I mean, there were kids today that when they figured something out, they were so excited.
I think I found the answer? Oh my god, just by doing all of this, I think I already found the answer. Look.
We do things in math class that we can do for reading and for writing and for understanding nonfiction text. All of it is, very fluid. And so when you start using these types of techniques and this kind of pedagogy, I think that you end up seeing how successful kids are throughout everything.
Thank you for sharing. I see people are still working on the problem, and that's great. It's really a great problem. When we post it in our YouCubed workshops, by the way, come to our YouCubed workshops because they're fantastic. This is some of the work teachers have done. I love this poster on the left where they're really thinking about why are these numbers solutions, and they have a conjecture about that. And then the people on the right made a visual spacing of the numbers that worked. So I always love that. So big ideas. The big idea of this lesson is factors and area models, and look at all the standards that come up when you teach a big idea task like this. I particularly loved all of these things I have on this slide. One I wanted to highlight was the students talked about the connection wall. Sarah puts up big ideas in maths topics on the wall, and she asks students, when you see a connection between two ideas, then they write it on a little post-it note and she connects them with a piece of string. She told me at the end of the year when she took this down, the students all wanted to take their post-it notes home with them. They were so proud of coming up with those connections. So I love that because math standards strip away all the connections in maths. And so she's really working to bring them back. I won't tell you about our calculus class now. I'll move on from that. But what I wanted to do now is tell you about a big idea that's inside Mathish. And this is that big idea. I make an argument that in maths classrooms, maths is nearly always precise. But in the real world, when we use numbers, we nearly always use what I call ish numbers. And I'm going to give you some examples. So maybe you're chatting with your kids and you're asking them, how much of the moon can we see tonight? Or maybe they're saying, how long is the drive to the airport? Or how old are you? Or do you want half of my pizza? How much paint do I need to paint the wall? How much rain fell last night? How many people are in this crowd? I could go on and on and on. I could give you a million examples. They would all be maths that we use ish numbers with. And of course, students only ever experience fractions in the real world in an ish way. So I think we're kind of out of balance because maths in classrooms is nearly always precise. It's a very precise subject. But in the real world, and this is an ish answer, probably about 80% of the maths is ish. Now, it turns out that when you think in an ish way and when you think in a detailed way, that those are really different ways of thinking. Thinking in an ish way actually is a more conceptual thinking. It's not about the detail, it's about the conceptual ideas. It actually activates different brain regions, which is always a good thing. So I want you to try it and ask you if you would ish, no calculating, no precision, what would be your ish answer to 280 divided by 9? So I see some people saying maybe 28, 30, 31, 20, 30-ish, 31-ish. And I will say to you, well, first of all, I can tell you the precise answer looks kind of like this, bit of a gnarly calculation, 31.111 recurring. But this is what I want to say to you. If you can ish the answer, and I see you can ish the answer, that tells me you have a sense of the numbers, or what we would call number sense. But most students, as many teachers will say, don't have number sense. And in fact, if you ask them to ish an answer, they'll go, oh, I have to calculate it. So we have a Facebook group at Stanford, YouCubed, a YouCubed Facebook group, has over 30,000 teachers in it. It's really a great place. Teachers will post in there, oh, I'm teaching whatever tomorrow, I don't know what to do, and 15 teachers will share lesson plans. It's a very supportive, great place. But this was a post in our Facebook group this summer. Suzanne said, I'm starting to feel sad about young and older students that when asked to divide 272 by 8 mentally, they'll try and do long division without a real feel for it. Same for adding and subtracting mixed numbers. Many students change them into improper fractions with a common denominator. They lose most sense of the numbers along the way. Is it that we don't take enough time for teaching understanding? Is there not enough time for instilling the joy of number sense? So yes, I agree with Suzanne that time is a really important piece, but I have a solution. So everybody listen to this part. My solution for this number sense problem is this. Before students ever do a calculation, we should ask them to work out the ish number first. Now, some of you, when they do that, their brain has to be staying at that conceptual level, not jumping in and calculating, but thinking conceptually. Now, you may be thinking, well, I already get my students to estimate. What's the difference between ishing and estimating? And this is what I will say about that. We do ask students to estimate, and usually they hate estimating. They will groan, and often students will work out the precise answer and then round it off and say that it's an estimate. But when we ask them to work out their ish number, it's completely different. It's quite magical, and I'm going to show you this on video. Something amazing happens to kids. It frees them up in ways that estimating just doesn't do. I can also share with you that ishing really helps with standardized test questions. So here's a test question that was given out across the United States to 13 and 17-year-olds. And I'll ask you the question first. They were asked 12/13 plus 7/8 is closest to which of those? 1, 2, 19, or 21? And I can see that you all think the answer's 2, which is correct. But what do you think was the most common answer given by both 13-year-olds and 17-year-olds? Yeah, you know your kids. So most common answer was 19, and the second one was 21. So we can probably groan at that and go, oh no. But I would say these kids who are answering 19 and 21 have probably never ished answers. If they got used to ishing answers a lot, they wouldn't say 19 or 21. We know what they're doing. They're diving in and calculating and thinking they have to work with the numerators or denominators. They're not thinking conceptually about this question. So I also can tell you that this is not just me saying ishing is great. Researchers know that estimating predicts kids' maths achievement all across the grades. Getting little kids just to ish, where would this number go on a number line? That keeps them at this conceptual level. It is just super important all through the grades. I can also share with you that anytime we do a real world task with kids, and I hope we do those often, the numbers are going to be ish numbers. I was in a presentation that Graham Fletcher gave last year at the National Maths Conferences, and he started his presentation by showing this video. He was giving us a maths task. So this was the video Graham showed. So somebody's asked the question, does ishing mean to question what the numbers mean first? No, it means just give a rough answer. Don't be precise. Just what would be your rough answer, which in the English language, ishing is a good translation of that. So yeah, here's Graham. When I was in this presentation, I'd never seen one of these contraptions before. I've now learned it's an apple peeler. And so he showed the apple being peeled, and then he gave us some info about apples, and then he asked us how long would the peel be? So great question. Lots of things to work out. I can tell you that in that room full of math educators, none of the tables got the same answer. Everybody got a different answer. Why? Because of course it's not precise. None of these are precise. You have to ish your way through it because it's real. So these are my two little characters. We have Ish, who's fluffy and soft, and Precise, who's kind of pointy. And I did want to share with you what I'm not saying, because I am quoted so often, misquoted so often in the press. You wouldn't believe what is said about me, that I believe. I can't believe what I believe when I read what people say in the press, what is written in the press. But I am not saying that precision is not important, because of course precision is important and we need that in maths a lot of the time. But what I am saying is that we need both and that they need to be in balance. So this was a research study done in the UK where kids were asked, just draw a picture of your maths lessons. So we can see the top picture. If you look at it, the teacher's in the corner going blah, blah, and the kids are going boring. The bottom one is really epic. We see the maths jail in the center of the picture. And then somebody, a kid or a teacher at the top saying, no, that's wrong, 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 wrong. So I know, and you probably know too, that this is what kids are afraid of. They're afraid of this maths precision. They are afraid of being wrong. That makes maths a really scary subject for them. And one of the things I love about asking kids to ish numbers is it not only has them thinking conceptually, it not only is connecting them with the maths in the world, but it really takes the sharp edges off maths for kids. And we're going to see this in a video. So you can do lots of things with Mathish. One thing you can do, we can try this now, is have a little game show. So let's play This is how you play Mathish. I'm going to give you a maths question, and sorry if it's too loud, and you are going to ish the answer. So do not calculate it, just ish. So here we go. Here's your first question. So I can see you can all ish this and you're doing great. And if I was in the classroom, I would ask what your approach was, and we could chat about the different ways people ish this. Of course, you know, though, that students do not ish this in their NAEP test questions. They sit and they subtract and calculate. Here's another one. What do you think of this? A little bit harder. So we know that this is a division question. A perimeter has an area of 376, and we know one side length is 13. And again, what is your ish? What is your sense of this? What's your conceptual thinking about it? So I'm showing you these different examples to show you how you can. It's really valuable to come up with ishes in lots of situations. Let's have a look at a third one. Somebody's asked me the answers. I'm not going to tell you the answers. You're going to figure those out. But so this is a great activity. You can do it in the classroom, have kids drop a load of dice on the desk and work out the sum of them by grouping the dice. It helps with groupitizing. We have a lot about that that's in my book too. But yeah, ask kids, what do you think? Ish your answers. You will find they have lots of different strategies. Some people will say, well, I group tens. Maybe some of you did that. Some people will say it's dice. So I thought the average would be 3.5. So I multiplied 3.5 by 35 or 3 by 35. All sorts of different ways of approaching it, which I love. So I first presented about this ish idea last December at a conference at CMC in California. And my favorite thing happened. I presented about it, went back to Stanford. A week later, I got an email from a teacher. And this is the email I got. She said, I was at your presentation this past weekend and I was able to teach my students about ish numbers, and we used it in class. I teach 6th grade. Had the students find an ish number for unit price before they calculated. Even my less confident students were getting involved. And when we did calculate it, the students could see if their ish answer was close. If not, they talked about why. I was amazed at how much conversation I got. Today, while they were working, I heard students helping each other. And to start off, they were asking each other, what's your ish number? So I loved that. And of course, I wrote back to Shelby and said, fantastic, can I come and watch? So I'm going to play a video from Shelby's classroom. Shelby was in her 3rd year of teaching, so she's new-ish teacher, but took this on. And these are the activities. This is what she taught. This is what she gave the students that day. Oh, yeah, give us this. So one of them was she asked the students, how many soccer balls ish? And they ished their number. Another type of question she gave them, she asked them, what is the ish ratio of purple to green balls? Another one she asked them is, what is the ish ratio of cats to dogs? So she's getting them to use ish with number sense, with ratio. So let's have a look at the video. One thing I'd like you to really look at is while we were videoing this that day, the principal was in the room beaming from ear to ear. And she said to me afterwards, oh my gosh, these students who are putting their hands up and sharing are the ones who are usually sent to the principal's office. And this is what I'm hearing from teachers over and over again. It brings in kids who fear maths and normally really disengage. So I'll tell you where the tasks are in just a sec. So let's have a watch of ishing with Shelby's 6th graders. Thanks, Jackie. Hang on, Mathish.
So, you guys have all of your supplies on your desks. We have whiteboards, we have pencils, we have markers, erasers, rulers, and the pictures that we're going to be going over today. So you guys are allowed to use all of those materials to draw on any of the pictures or anything that you need to help you come up with your ish number. So we are going to get started. Where have you heard an ish number recently?
I've used ish numbers, for example, a soccer player maybe averages 2-ish goals, like if they're really good.
I thought like I have to be for a birthday party, I have to be like, let's say 6-ish
people, because there's like 8 billion-ish people on Earth.
Ish numbers help me get more creative with math because it helps me get to the answer quicker and it's more effective.
We are going to come up with how many soccer balls are there in this picture? How many soccer balls? So, who would like to share their ish number and how you got to your ish number? Come on in.
We saw that each soccer ball was like about half a centimeter. And then we saw that the picture itself was like 6 by 10.
It helps me see a math problem in like a different way. Like, for example, when I'm looking at a photo and I'm trying to figure out like how much is there, I can actually like enhance my brain to actually start looking at all the different ways of how I can calculate my ish numbers.
The students really grabbed onto the ish number and took off with it. Even the students who used to not speak up in class a whole lot are now raising their hands and can give me their ish number.
I don't really know how to explain it. Okay, so we counted the purple balls and we think there's like about 10-ish purple balls, and seeing that the green balls are still falling, there might be more of them. And so we counted like, I don't know, like
6 green balls so far. And then we thought there was more falling, and we got 7-ish green balls.
They are now confident that their ish number doesn't have to be exactly correct. They just have to explain how they got to their ish, and it's close enough to the right answer that now they have confidence in themselves and in their math abilities.
So we use our ish number to say like 30-ish dogs and 20-ish cats. So we simplify that to get 3 to 2.
In the first picture, I think there's like just a little more dogs. I agree with them, like 2 to 3. But in the other pictures, there's kind of like a pattern.
Ish numbers, they really help me understand math in a different sense. Whenever I'm doing a problem, I always feel like by double checking, I just waste so much time going over the entire thing. I feel like I'm doing an equation 2 times. But by doing ish numbers, it's like I'm checking it before I actually do the problem. So that way I can actually figure it out faster, quicker, and it's better.
Ish numbers can help us get to precise answers, but not only does it help us get to the precise answer that we're looking for, it also can help us with the understanding of the mathematical concepts and mathematical situations out in the world.
It's really important for pricing and timing. So like timing is another way, and like Adele said, water like or gallons, you need to know how much cups you need to have. So like I think they're important because like they can help you a lot. Yeah, like it's in the real world, like it makes your life easier too.
I definitely think ish numbers have changed the environment of the classroom, and my students who really were not fans of math, were struggling with math, now have the more confidence with their ish number and knowing that I'm not looking for an exact answer, but I'm just looking for how they got to their ish number. Do they understand the math behind how they got there, the conceptual understanding of the actual math?
So there you see ishing in 6th grade. What do you think? I'm looking at the chat and people's discussions, which is great. Yeah, is there a word in Portuguese? This book is coming out in Portuguese, so I guess they're going to figure one out for the translation. Yes, Charlene, Shelby's video is on. I have a new website I'm going to show you in a sec called mathish.org, and it's on that website. It's also on YouCubed. And maybe somebody can share that link because I can't really share it while I'm presenting. But yeah, do keep sharing what you think about ishing. Thank you. Somebody's sharing there's the video link. You guys are great. So yes, I think ishing is actually a great way to live your life. Since we've been talking about ish in the YouCubed office, where we can't stop now. So we're ishing all the time. We're ishing all over the place. And I really, as I said, love, it is the same as estimate, but it's different for kids. When you ask them to ish numbers, it's totally different to asking them to come up with an estimate. So try it and tell me what happened. I love to hear. So I think ishing has 2 purposes. One is it's valuable for questions in the world, so kids see the connections, but also it's valuable as a teaching approach. I put in maths classroom into Shutterstock, and this is what I got. Shutterstock is a photo place, and probably pretty accurate. A teacher puts up a number question and 1 student has their hand up. But I proposed that if instead she were to ask them the ish question, that all the students are willing to share. And that's what we're finding in classrooms now. Some of you may know this book. It's an amazing book. And oh, great. Thank you, Catmo. Amazing book about, I didn't know it. Teachers, when I was presenting, told me about this book. It's about a boy, similarly, who becomes unlocked in his art by ishing. Yes, you can ish numbers in calculus, Ricardo. And I got in touch with the author, actually, Peter Reynolds, and said, I have a book called Mathish, and he wants to collaborate. So we'll see where that goes. You can also use ish, of course, across subjects. We know about art, science, the science teachers in Shelby's school are all getting the kids to ish in science. And I have an undergrad who's now looking at ishing in language arts, because language arts can be very locked up and rule bound also. But generally, this is what I love about ishing, that it makes kids feel more free, and they really need that in maths. You probably agree. So in case you're asking, like, what topics could I do this with? Yes, I see it in ratio. I went through the math standards and pulled out some topics for you. And yeah, there's quite a few topics where we can, when kids are graphing, we can ask, it's not just numbers. Before kids draw a graph, ask them, what do you think that graph's going to look like? It will cause them to pull back and be at that conceptual level as they do that. So some other things I wanted to share with you. I have a new website called mathish.org. Please buy my book. And if you want to buy it in bulk, which I know you do, you can find out how to do that on that website if you want to buy it for everyone in your district. Bought, thank you. On Mathish, you'll see there's a lot of things that I didn't get into the book or don't work in a book. So one is there's this lovely comic introducing Mathish to your students. There is definitely high school applications. Don't worry about that. There's some handouts. Like, one of the ideas I talk about in the book is the importance of kids, instead of doing homework, which is just more of the same, instead reflecting, what was the big idea we learned about today? What was something I struggled in? You could have them print this out and have it in their books and have different, I'm enjoying the chat, have different questions that students ask on different evenings. Some more things. This is in Mathish, I really build up to this teaching model. These are pulling from really research in learning, research in cognition, research in expertise, research in neuroscience. All of these things come up as what's really important for kids, helping them learn how to learn. I talk about metacognition in the book, encouraging them to struggle. Somebody, when we were watching the video of the penny task with Sarah teaching, somebody wrote in the chat, it's so scary to use these tasks in the classroom. And I really appreciated that honesty and vulnerableness, saying this is scary. I think part of that fear for teachers is thinking you have to know everything that's going to happen and you have to be the expert on everything kids come up with. And that's really not the case. What we want is to have kids be in a safe environment where they can struggle and feel okay about struggling. And doesn't matter if you don't know the answer as a teacher. By the way, I should share with you, and I didn't have a slide on this, but I want to share with you, we're about to release one of the most amazing units of work we've ever made on YouCubed. I'm so excited about it. We're releasing it on Monday. If you are signed up to get emails from YouCubed, you can just sign up at the top of the website. You will get an email about it. But this is what we're releasing on Monday. We have collaborated with Stanford women's basketball team, and we've made a unit on sports data analytics in basketball, where the kids get to watch. The players have made videos for kids, and they get to play a bit, and they get to investigate data. It's an amazing unit. Comes out on Monday. Please check it out. If you do get my book, please write a book review. As I said, I've got these really nasty people who have targeted me, and they love to write all sorts of horrible things. So please help me out with that. And as some people are talking about, there's a plushie. Here they are, my plushie. And I got this made. By the way, do you notice this little character is British? Do you get it? British. Anyway, it's a British plushie, and I made this because teachers said to me they wanted one for their classroom to remind them to ish. But we didn't make many because I'm not going into toy production. You can buy them on the Mathish website. When they're gone, they're gone. That's it. But yeah, this is my little ish. So other things I wanted to share. There are no other things. Okay. So I will stop sharing there and say, oh, we've got 10 minutes maybe for questions. So I'm going to look at some of the questions in the chat. Thank you, Elise. I think they are threatened. It's true. But if people want to unmic and ask a question, I don't know if that's going to be too crazy with 1,000 people in here. So the basketball unit, Christy, that's coming out on Monday, is just called the basketball unit, I think. I don't know what the name is yet, but it's packed with great videos for kids to watch, and all sorts of other things. People are raising lots of questions. Great. College basketball fan. Love it. Yeah. Oh, Kyle says, raise your hand if you want to unmic. Great idea, Kyle.
And that'll help us out here. So feel free. It sounds like Joe wants to interact here, friends. So be brave if you want to raise your hand, and then we will manually invite you to unmute your mic, and you can ask away.
So somebody's asked a question. Good question. Crystal says, if the standards are too thin, I think that probably means, do you have a recommended sequence for children? So we're still teaching to standards. It's not about not teaching standards, but what we've done is we've grouped standards into more conceptual pieces. So it's not so small and bitty. I'm going to show you YouCubed here. And by the way, this is how you sign up for newsletters. See that little orange button at the top, and you'll sign up for that. You'll get an email with all our new things, and this is our professional development. So, but yeah, if you go to the big ideas and teaching to big ideas and go on to this guidance, you'll see it's not that we don't have standards. They're just grouped. So this is TK. This is grade 1. This is kindergarten. So this big idea has all of these standards inside it. So yeah, other questions? I see people
There are. I'm going to invite our first
Okay.
hand raiser, and it should invite you on your screen there to share away. Let's see if the mic will go on. A little bit of an experiment here. There we are. You are live, my friend. Ask away.
Hello. Thank you for this wonderful session. My name is Olu. I'm a parent, and I'm marveled at this new-ish way of learning maths. I have an autistic child. So how do I help this child to comprehend maths? He loves numbers, but everything seems to get jumbled up at times. So I need what resources are available to help my child. He's lagging behind already because most times he's taken out of the class. So he's way behind what he should really be learning. And I know he can if he really gets the resources, the support that he needs.
Wow, that's a really hard question. And I know that there are experts who have a lot more expertise than I do in how to help students with particular learning differences. My nephew also has autism, so I know a little bit about it. But I would say, as we haven't got much time, we have a section on our YouCubed site on special education, and have a look at that, where you do see some of the people with expertise on different special differences, because I probably can't give really good advice.
Awesome. Well, that gives a great next step. We have another question here from Raquel. I'm going to go ahead and hit the ask to unmute button. So take it away.
Awesome. Thank you. Hello, Dr. Boaler and everyone. I am Raquel Fullerton from Chicago. My question for you is, just to give you a little context, I recently became the math specialist for our new campus, Dominican University, where we are specializing in serving Black and Brown students to get their associate's degree. And my question for you is, what do you think, or do you have any research or experience in what math-ish looks like in the college setting?
Well, what I would say, and ishing is new. This is my new book, and it hasn't got out there as much yet as it will in the system. And I haven't seen it in college classrooms. I'd love to, but what I would say is really any problem you're doing, whatever the problem is in a college classroom or a high school classroom, you can ask kids, what would your ish answer to this be, before you go in and do this formal calculation. And that really extends across all grades. So yeah, try it with your college students and let me know.
Fantastic, fantastic. And let's see, I see we still have a few more minutes, so I'm going to go ahead and invite our next questioner. Dearshay is my apologies, pronunciation of your first name there. Feel free.
Oh, you're fine. My name is Shay. I'm very interested in learning much more. I'm an upcoming elementary school teacher, and I see that this session, is for the whole weekend. Is there more to it, or is it the same thing talked about each night?
Oh, Kyle and John.
Yeah, I was going to say, Joe's like, wait a second, I'm not sure if I know the answer to that. That's a great question. So there are over 40 sessions. The majority of those sessions are all live, and they are spread across different grade bands. Some are very content focused, some are mindset focused, some are leadership focused. So that's a great question. I would definitely take some time here tonight. We have 2 more sessions coming up at 8:15 Eastern time, so Eastern North American time. And after that, throughout the rest of the weekend, there's going to be quite a few sessions happening, some simultaneously and across all grade bands and topics. So for example, some folks are really, really honing in on one of our sessions that is on fractions, right? So if you want to talk about a topic that is traditionally a challenge for not only students, but for teachers to teach, is the concept of fractions. So going into this world in a conceptual manner is going to be taking place. So definitely take a look. Great question. And
ish fractions. It's a great way to approach fractions is by ishing them. I can answer just a couple of questions from the chat as we
go for it.
Wind down. Does the plushie ship to Canada is an easy question. Yes, plushie ships internationally. Somebody said, do you have any experience teaching ish numbers with students with dyscalculia? I have several students in my class. I am hearing from educators that this is going fantastically well for kids with special needs. It's unlocking them in all sorts of ways. So I would say definitely try that. And Elaine, I like your idea. Would you please create a short video under 10 minutes for students for all ages discussing the importance of both procedural fluency and conceptual understanding in maths? Okay, I could do that. And some people are answering the question for the child with autism, which is great. Can you address the difference between teaching math and reading? In reading, for example, we teach phonics and foundational skills using direct instruction, but in math, we don't necessarily want to teach that way. Reading is very different from maths. I really don't like this idea that what we've learned from reading about phonics should just be transferred to maths, because learning to read is learning these different words, which you can do through phonics, through breaking them down, through repetition. But to understand a mathematical concept is a very different endeavor. And one of the things I could have talked about that's in the book is how important it is to develop mental representations of these mathematical ideas. You really learn a mental representation. You learn something really deeply by drawing it, writing about it, holding it in your hand, building it. That's what builds those mental representations. So one of the examples I have in my book is I could ask you all to think of a stapler, and I bet everybody has a mental representation of a stapler come into their head. because when you think of a stapler, you can probably think about what it looks like, what it feels like, what it does when you interact with it, what it looks, all sorts of things about a stapler that builds up that representation. And we need that for maths. Kids should be developing these really solid mental representations. So different from reading, definitely different from reading. Thank you for the great comments. Why do you call it maths? It is, thank you for the answer to that. I call it maths, both because I'm from England and that's what we call it in England, but also it's shortened to maths because it's short from mathematics. It's short for mathematics, which is really meant to denote all the ways of being mathematical. And I don't love math. It sounds so singular and narrow. And when people say do the math, they really mean do a calculation. So I tend to keep maths as the name because it seems to better describe this broad subject of mathematics. So
You need like a campaign for us North Americans to call
yeah.
it.
I mean, you just gave some pretty logical reasons, but I mean, you could go to the first one and say, no one says mathematic, so right there, I mean, that, you convinced me. So I like it. Joe, I want to thank you. I want to thank you on behalf of the 1,400 people that were watching, because we were streaming on YouTube for the overflow. There were about 1,400 at the max. A great audience here. A lot of conversation happening inside the Zoom room, but also a lot of conversation happening over on YouTube. So definitely a place for people to go and leave some comments, leave some big takeaways.
Where do I go to that? How do I find that?
You know what? Maybe John, if you want to
link in the chat
that link, yeah, we'll toss it in the chat. And we'll encourage even those who are in the chat to share it. Because again, as we share, we're going to reach more and more math educators around the world so that they can come into this great learning experience, not just in this one session, but also all the sessions all weekend long. There's always so many takeaways. So John just dumped that into the chat. Remember, my friends, we are going to give something away here. So what I think we're going to do is actually, and John, I'm going to put you on this task, unless Jill wants to be the selector, but we want you to put a big takeaway into the chat. We saw some already. You might have to repeat yourself a little bit, but we want to see the chat go crazy here. And then we're going to pick someone for the book giveaway from Corwin. You'll see there's some great options on the screen there that you might be interested in digging into. And once we select you, we'll have you send us an email so that we can make that connection with Corwin so they can send that book on. So I see a bunch of great responses in the chat so far. If you haven't, and you are a district leader, we encourage you to have a discussion about your math program and how we can strengthen all 6 parts of your mathematics tree. You'll see a QR code up on the screen here, and we'll also drop a link into the chat. And remember, your certificates can be found on the Summit site. So go ahead and head over there at the end of the weekend and grab those certificates. And finally, if you're looking to stretch the replays to as long as a month or beyond, as you see here with our full access pass, you can do so on the Summit site by heading in there and clicking on the ticket button. So friends, this has been an awesome session. John or Joe, have you found our winner for this book?
I gotta let Joe scroll. Just Joe scroll and then just point to one. Unless you've been reading in all of them, because then pick.
It's hard to keep up. This is quite the waterfall of.
There's already 97 and I stopped scrolling. She's muted.
All right, I couldn't speak. All right.
There she is.
We must have locked her out.
I was going to say, I'm like, she's really digging here. I wasn't sure.
All right, you want me to choose a winner? I've taken loads of pictures of the chat. By the way, can we download the chat?
Yeah, I saved it. There's a little button at the top, the 3 little dots. If you're in the chat, click that, and it just says Save Chat. And I think
Let's go for Bridget Steele.
Bridget Steele. Congrats.
Awesome stuff. We
Bridget.
will write that down. Bridget, reach out to us. You can hit reply on essentially any of the email reminders that you received from the summit, or admin@makemathmoments.com. That'll help us get in touch with you for information on how we can get that book to you. Friends in the chat, we so appreciate you. You're taking your Friday evening or Saturday morning or Friday afternoon or wherever the heck you are to join us, and really in order to grow your own math minds so that you can be better for your students and children everywhere. So good on you for all of that. Joe, we want to thank you again for being a part of the summit and being a guest on the podcast so many times before. And friends, we are getting excited for our next session that begins in about 11 minutes.
Yeah, 11 minutes. There's two sessions.
Dashboard.
2 sessions, folks, there to choose from. We
I
have
just say
Sue
one thing?
Looney. We have Sue Looney, who's going to be presenting around early math matters, experiencing powerful routines and from counting. Also, we have Crystal M. Watson presenting at the same time. So you have to make a choice here to go live. And her session is on from teacher to facilitator, encouraging and supporting authentic mathematical discourse. So those 2 sessions, you can go back to the main site. You probably also got an email for each of these sessions if you registered for them. You can head there. It will bring you to the main site, which is summit.makemathmoments.com. This is where you registered. At the top in the menu, you should start seeing the links to those sessions to kind of get ready. To click into them, and then also you will also see replays in there. So this replay will actually go up at the top. As soon as the replay is available, you'll see a button on the website that says replays. That's where you're going to find all the replays throughout the weekend as well. So we will see you over there, folks. Thanks so much, and Joe Boaler, thanks so much for being here and kicking off the 6th annual virtual summit. Thanks so much.
Take care, everyone.